Hi students, this is Alex here. In this video, we are going to discuss about integration of rational functions by partial fraction method. Rational function is one where we have the expression in numerator and denominator, but degree of numerator should be less than the degree of the denominator. Then we call it as a rational function. For example, let's take the first expression. The degree of the numerator is the highest power, which is 2. In the denominator, when we expand, we get x cube and the degree is 3. So degree of numerator is 2 and degree of denominator is 3, and we notice that degree of numerator is less than the degree of the denominator. Such an expression is known as the rational function. We have three basic rules for using in the partial fraction. Suppose if the denominators are converted as a factors and we see all are different factors. In the first expression, we have x minus a, x minus b, x minus c. All the three are different factors. So when we have a different factor, the rule is we take a constant a divided by the first factor x minus a, then plus constant b divided by the second factor x minus b, and constant c divided by the third factor x minus c. So in this way, when all the three factors are different, we write a by first factor plus b by second factor plus c by third factor. Then the second rule, we have x minus a whole square in the denominator. It means the repeated factor, the same factor x minus a is repeated once again. So we have x minus a whole square, and x minus b is a separate factor. Here the rule is we have to write constant a by x minus a plus constant b by x minus a whole square. So this is the rule when we have a repeated factor. Suppose if there is a power 3, then we write a by x minus a plus b by x minus a whole square plus c by x minus a whole cube. But we have square, so we have to write power 1s, that is power 1, then power 2. So a by x minus a plus b by x minus a whole square. Then for the third factor, it is x minus b. It is similar to the previous one, so we just write constant by the third factor x minus b. Then coming to the third rule, we have a quadratic expression as one of the factor which cannot be factorized further. If this is factorizable, then we go for the previous two rules accordingly. But here we have a quadratic expression. But x minus a is a linear factor, so as usual we write a by x minus a. Since it is a quadratic, instead of the constant b, we have to write a linear term, that is bx plus c by the quadratic x square plus bx plus c. So when we have a quadratic expression, we have linear term in the numerator. When you have a linear term and in the numerator we have the constants a, b, c. So these are the three basic rules. Now let's solve some of the problem based on these rules. Let's take the first problem where we have integration of 3x minus 1 by x minus 1 into x minus 2 into x minus 3. We notice that three different factors. So as per the rule which we discussed here, we have to follow the first rule, a by first factor plus b by second factor plus c by third factor, because all the three factors are different. So let's take this expression alone, which is 3x minus 1 by, then we are going to apply the rule a by first factor, which is x minus 1, plus b by second factor, which is x minus 2, plus c by third factor, which is x minus 3. We are going to take LCM here. The LCM is nothing but all the three factors product, x minus 1, x minus 2, x minus 3. Now a will be multiplied with these two, that is a into x minus 2 into x minus 3, plus with b we will multiply x minus 1 and x minus 3. So b into x minus 1 into x minus 3 plus c into x minus 1 into x minus 2. Now we find both denominators are same. So I'm going to equate both sides numerator. So it is 3x minus 1 equal to the entire numerator. Now let's take some value for x to find the constant a, b and c. Let x is equal to 1. When I put 1 here, it is 3 minus 1, which is 2, equal to a into 1 minus 2 is minus 1, 1 minus 3 is minus 2. then the remaining terms will become 0 because when I put 1 here, b into 0 and here also c into 0. So other two terms are 0. So from this we get 2a equal to 2 and value of a is 1. In the same way, let's take the another value. For example, let's take x as 2. When x is 2 here, 3 to the 6, 6 minus 1, 5. 5 equal to, this part is 0. So no need to write. Then coming to the second term, b into 2 minus 1 is 1. 2 minus 3 is minus 1. In third part, again we have x minus 2 as a factor, so it becomes 0. So totally the value of b is minus 5 from this. B equal to minus 5. Then let's take x as 3. When we take 3, here it is 3 into 3, 9, 9 minus 1, 8 equal to, first term will become 0 because we have factor x minus 3, even second factor will become 0. In third factor, it is c into x minus 1. So 3 minus 1, 2 and 3 minus 2, 1. From this, if I divide by 2, we get c value as 4. So we got the value of a, b and c. This we are going to substitute in the place where we applied the rule. So instead of integrating this, I am going to take this and integrate. So now integration of a value is 1 by x minus 1 dx. Then plus b value is minus 5 by second factor dx. Then third term c by x minus 3 dx. So what are the expressions given? We resolved into partial fraction, and after finding a, b and c, we are using that term to integrate. And the first term is log mod x minus 1, then minus 5 log mod x minus 2, then plus 4 log mod x minus 3 plus constant c. Let's take the another question where we have 3x minus 2 by x plus 1 whole square into x plus 3. So we notice that there is a repeated factor. For repeated factor, we are going to apply the second rule. That is a by x minus a plus b by x minus a whole square plus c by x minus b. So we have to take the expression. We are going to apply the rule. This is equal to a by x plus 1 plus b by x plus 1 whole square plus c by x plus 3. Now we are going to take LCM. LCM is nothing but the highest power between these two is only x plus 1 whole square. So x plus 1 whole square into x plus 3. So a will be multiplied by the LCM. So x plus 1 and the square gets cancelled. So remaining will be only 1x plus 1 and x plus 3. In the same way with b, if I multiply this LCM with the second term, x plus 1 whole square will get cancelled. So we have only x plus 3. And with the c, when I multiply this term, x plus 3 gets cancelled and we have only x plus 1 whole square. So from here, we can see both the denominators are same. So we are going to equate the numerator of both the sides. So 3x minus 2 equal to this entire term. Now we have to take value of x as minus 1. So this will become minus 3 minus 2. So we get minus 5 equal to, this term will become 0. Even the last term becomes 0 because we have x plus 1 as a factor. When I put minus 1 here, we get b into 2. So from this, the value of b is minus 5 by 2. Then in the same way, let's take x as minus 3. When I put minus 3, minus 9 minus 2, which is minus 11 equal to, this factor becomes 0, this factor becomes 0, and we have c into minus 3 plus 1 is minus 2 whole square, which will become 4. So the value of b is minus 11 by, when you squaring it will become plus 4, so minus 11 by 4. Sorry, the value of c is minus 11 by 4. So we got the another value. Now we have to find one more value. For that, we cannot take some x value to make some factor 0 because already there are two factors x plus 1 and x plus 3. So based on that, we have taken x as minus 1 and minus 3. Now there are two methods to find another value. Simply take some values for x, get to an expression, in that substitute the value of b and c, we get a. But easier than that, we have another method. Let's compare the coefficient of some terms on both the sides. Suppose if I compare the coefficient of x square on both the sides. So on left hand side, we don't have x square term, so which is 0. Here, after multiplying x and x, we get x square and its coefficient is a. And here, b, there is no x square term. And here, when I expand, I get x square. With that, we have a coefficient c. Already, we know the value of c here. So by substituting 0 equal to a minus 11 by 4. And I can carry this term to the other side. So a equal to 11 by 4. So we got the value of a also. After getting these three values, we have to substitute in the rule and integrate. So a by x plus 1. So let us take the a value, integral 11 by 4 by x plus 1 dx. Then b is minus 5 by 2. So minus 5 by 2 by x plus 1 whole square is the second term. So minus, I have taken the minus sign outside. So pi by 2 dx by x plus 1 whole square. Then c value, here it is minus 11 by 4. So minus integral 11 by 4 dx by another factor is x plus 3. So we have x plus 3. Now on integration, the first term is 11 by 4 log mod x plus 1. Then this is minus 5 by 2 and integration of 1 by x square is minus 1 by x. Instead of x, we have x plus 1. So already there is a minus sign. So let's make this as plus into 1 by x plus 1. Then this is minus 11 by 4 log mod x plus 3 plus constant c. Then after this, it is possible to combine the first term and the last term because both are having 11 by 4. So let's take 11 by 4 common. Then this will become log of log a minus log b form. So log a by b, x plus 1 by x plus 3. Then plus 5 by 2 into x plus 1 plus c. Now coming to the next problem, we have in the denominator x plus 2 and another factor x square plus 1. This is non-factorizable quadratic expression. So for this, we apply the third rule, that is linear function when you have, that is linear factor when you have, the numerator we have a constant. But when you have a quadratic function or quadratic factor in the denominator, we have to write a linear in the numerator, that is bx plus c. So this rule we are going to apply. So let's take this expression alone separately, which is equal to a by first factor x plus 2. And for the another factor quadratic, which is x square plus 1, we have to write bx plus c by x square plus 1. Now as usual, we have to take LCM. The LCM is nothing but both the terms x plus 2 into x square plus 1 and a into x square plus 1 plus bx plus c into x plus 2. We find same denominator, so we are going to equate the numerator on both the sides. So x square plus x plus 1 equal to a into x square plus 1 plus bx plus c into x plus 2. Now let's take x as minus 2 because this term will become 0. When I put minus 2 here, when I square it will become 4, then second term will become minus 2, then plus 1 equal to a into minus 2 square is 4 plus 1, which is 5. and this entire term is 0 because we have a factor x plus 2. So from this is 2 plus 1, 3. 3 equal to 5a, and from this the value of a is 3 by 5. So we got the value of a. Now in this type of expression, it is better to use the second value as 0 for x. So this will become 1 equal to, when I put 0 here, it will become just a, and when I put 0, this will not be there, only c will be there, and here only 2 will be there. So it is 2c. Since we know a, we can substitute to find the other constant c. Let's take this 3 by 5 to the other side. So this is minus 2 by 5, sorry, 2 by 5. After taking LCM, this will become 5 minus 3, which is 2. 2 by 5 equal to 2c. After cancelling this, we get the value of c as 1 by 5. Now, we have to take another factor, but it's not possible here to make some values as 0. So we go for comparing coefficients on both the sides. So comparing coefficient of x square on both sides. So here we have x square term, the coefficient is 1. So 1 equal to, on the left hand side it is 1. On the right hand side, this is x square into a. So a is a coefficient of x square. In the same way, we multiply this bx with this x, we get bx square. So we get plus b. Now the value of a is 3 by 5. Let's substitute here. From this, we can get the value of b. So 1 minus 3 by 5 equal to b. So from this, b is, after taking LCM, 5 minus 3, which is 2. So 2 by 5. So we got three values of the constant a, b and c. Now we are going to substitute that in the step where we applied the partial fraction rule. A by x plus 2. So a value is 3 by 5. So 3 by 5 by x plus 2 integral dx. This is the first term. Then second term is bx plus c. b is 2 by 5. bx plus c. c is 1 by 5. Divided by, we have the another factor, quadratic factor, x square plus 1. So this is x square plus 1 into dx. But for integration purpose, we have to split this into two parts. So let me write the first part. 3 by 5 is constant which can be taken outside the integration. So integral dx by x plus 2. And here I am going to divide individually by taking this separately and 1 by 5 separately. So here 2 by 5 is constant which we can take out, x by x square plus 1 dx, and 1 by 5 is taken out, integral dx by x square plus 1. Now let's take this as I1, I2, I3. I1 is nothing but 3 by 5 log mod x plus 2 and integration constant C1. Coming to the second part, in I2 we have to do by substitution method. Let's take t is equal to x square plus 1. From this, dt equal to 2x dx. Already there is a 2 outside, so including this 2x dx, we can write that as dt divided by t. Apart from that, we have 1 by 5. But this is 1 by 5 log mod t plus c2. T when I replace, this will become 1 by 5 log mod x square plus 1 plus c2. Coming to I3, it's a direct formula, x square plus 1, which is tan inverse x. So we have 1 by 5 tan inverse x, because tan inverse x differentiation is 1 by 1 plus x square. So reverse of that is integration, and we have integration constant C3. Now we are going to combine all the three. So I is equal to I1 plus I2 plus I3. So this I1 is, we have 3 by 5 log x plus 2. 3 by 5 log mod x plus 2. Then I2, we have 1 by 5 log x square plus 1. So plus 1 by 5 log mod x square plus 1. Then last part is plus 1 by 5 tan inverse x plus all the constants combined together as c.